Modern civilization runs on microscopic silicon wafers. Controlling advanced semiconductor fabrication means wielding absolute economic leverage over every digital industry on planet Earth. The global chip market is not a free trade system. A hidden oligopoly of elite foundries controls lithography, raw chemical inputs, and advanced IP, dictating technological progress. Creating advanced sub-2 nanometer microchips requires extreme capital expenditure. A single EUV machine costs hundreds of millions, establishing an insurmountable moat against potential competitors. To command the digital future, you must control physical production, bottlenecks. When you own the fab infrastructure, the world's largest tech giants must pay your price. Extreme ultraviolet lithography systems etch nanometer-scale circuits in absolute vacuum chambers. This technological precision forms the foundation of modern corporate dominance and artificial intelligence. Tech leaders analyze architectural schematics for next-generation AI processors. Without these specialized chips, global software ecosystems grind to an absolute complete halt within days. Heavy cargo transports move sealed wafer containers under armed escort. Securing microchip distribution is a vital matter of national economic survival and strategic corporate sovereignty. Subterranean vaults hold refined rare earth minerals like germanium and gallium. Controlling raw chemical inputs gives the Semiconductor Cartel total leverage over global supply chains. Wall Street investors watch semiconductor equipment stocks reach historic valuations. Capital flows rapidly into the elite companies that build the machinery behind the microchip monopoly. Behind dark glass walls, cartel executives sign exclusive joint patent agreements. They consolidate proprietary technology, ensuring no outsider can replicate their advanced foundry yields. Automated monorails transport silicon pods across sprawling cleanroom facilities. Operating 24 hours a day, these megafabs generate multi-billion-dollar profits with robotic efficiency. Government officials provide massive state subsidies to secure local foundry construction. Powerful nation-states compete fiercely to host the physical infrastructure, which powers modern global defense and commerce. High-power laser optics test microscopic circuit pins with absolute precision. High-quality control at the nanometer scale separates dominant market leaders from failing corporate hardware manufacturers worldwide. Command centers monitor global fab yield percentages in real time. Optimizing silicon production, even by a mere fraction of a single percent, yields hundreds of millions in additional corporate net profit. Chemical tankers carry specialized precursor gases through high-stakes maritime routes. Disruption at a single chemical bottleneck can freeze global technology production, instantly affecting all market sectors. Tech founders face severe operational distress as microchip allocation quotas shrink. Relying on third-party foundries leaves consumer tech companies vulnerable to sudden, severe supply chain restrictions today. Elite foundry owners walk through multi-billion-dollar construction bays. Building modern semiconductor fabs requires far more capital investment than traditional oil refineries or massive steel industrial mills. Armored transport trucks carry high-purity silicon ingots under heavy security. Protecting critical material inputs prevents competitors from disrupting fragile, highly complex chip manufacturing timelines worldwide. Three major corporations control over 90% of advanced semiconductor capacity. This extreme market consolidation gives the elite cartel unprecedented, unyielding pricing power across all global markets. Engineers calibrate precision mirrors inside optical lithography chambers. The vast complexity of reflection optics creates an unbreakable technical barrier for any aspiring corporate competitor in the industry. Enterprise executives sign multi-year chip allocation contracts to guarantee future production access. Securing fab capacity years in advance is absolutely mandatory for long-term corporate survival today. Subterranean mining equipment drills for high-purity quartz sand and rare earth elements. Raw material extraction remains the ultimate, indispensable physical foundation of all modern digital hardware today. Tech consortiums study critical maritime choke points on digital projection maps. Extreme geographic concentration of foundries creates massive geopolitical exposure for vital global technology supply routes. Automated diagnostic rigs test thousands of advanced enterprise processors simultaneously. Only the highest performing silicon dies are selected for all mission-critical enterprise-level AI data centers worldwide. Patent attorneys defend proprietary integrated circuit designs in high-stakes legal battles. Strict intellectual property enforcement secures long-term monopoly rents for the reigning elite chip cartel today. Cleanroom workers handle sealed wafer pods under sterile yellow safety lighting. Preventing atmospheric contamination is essential when manufacturing microchips far thinner than human DNA strands today. Venture capital partners review holographic models of next-generation foundry facilities. Funding cutting-edge semiconductor infrastructure demands multi-decade investment horizons from top institutional investors. Robotic arms package finished microprocessors into protective metallic shipping trays. From raw sand to finished microchip, the transformation requires thousands of precise, highly complex operational steps. Geopolitical advisors track international technology sanctions on curved command screens. Microchip export controls have become the primary strategic weapon in modern, high-stakes global economic warfare. Distillation towers refine ultra-pure chemical solvents required for wafer cleaning. Without chemical purity, measured precisely in parts per trillion, modern chip manufacturing fails completely and instantly. Corporate raiders launch aggressive hostile buyouts targeting niche semiconductor design houses. Acquiring specialized IP portfolios consolidates market power squarely within the reigning elite industrial cartel. Underground server vaults store proprietary chip layout files under maximum security protocols. Safeguards protect secret circuit schematics worth hundreds of billions from aggressive digital corporate espionage. Heavy rail cars deliver raw industrial quartz to high-temperature electric arc furnaces. Refining metallurgic silicon into electronic-grade purity is an intensely energy-intensive, complex industrial process. Corporate executives examine physical models of megafab industrial clusters. Integrating power plants, chemical refineries, and clean rooms creates an unassailable, highly profitable manufacturing ecosystem. Robotic wafer sorters process finished silicon batches inside pristine cleanroom bays. Highly automated precision ensures consistent yield optimization across millions of individual microchips produced daily. Software developers configure enterprise AI clusters inside massive server farms. Advanced microprocessors form the indispensable computational core of all modern artificial intelligence systems worldwide. Industrial water treatment plants process millions of gallons of ultra-pure water daily. Semiconductor manufacturing consumes immense natural resources to maintain pristine wafer standards worldwide. Cartel leaders track multi-trillion-dollar market caps as silicon demand surges worldwide. Controlling digital hardware yields greater economic power than traditional legacy energy corporate monopolies. The Semiconductor Cartel commands the physical foundation of modern technological civilization. Those who control the fabs dictate the future of global enterprise and capital allocation worldwide. The stoic founder looks out over a sprawling silicon corridor at dusk. The digital age rests entirely on physical foundries, and his empire controls the ultimate, insurmountable global supply bottleneck.